Good morning, grade 12s. Today the fluvial processes that we're looking at are river capture or river piracy, and then just a tiny little bit about rivers cutting through mountains. So the river piracy, let's just have a look at what it is. A river, an energetic river, has what we call headward erosion. This means right at the source of the river, it erodes backwards. And this backward erosion actually means that it can intercept another river and steal the headwaters. Then the same river, we call it the captor river, gets all of that additional water and is rejuvenated. The captive river, the one that's had its water stolen from it, becomes what we call a misfit stream, because now you've got this massive river channel that it was flowing in has now all of a sudden just got a small amount of water. Typical exam question, I'm going to show you the diagram later, but you would need to be able to label all of the features. Here we've got a super illustration. This is now a river before river capture happens, and here we've got an energetic river and it's flowing in this direction. You can see that's the direction it's flowing in. But later there has been headward erosion, and this headward erosion over here means that it's gone backwards, and it in fact intercepts another stream at this point here. And this is what it looks like after river capture has taken place. So this captor stream here has had its headward erosion. It eroded backwards, and it intercepted this stream here, and it has in fact stolen all of this water up that way, has gone into this captor stream. So the captor stream is now rejuvenated, a lot more energy. What we've got left is this tiny little stream down here at the bottom, and it's now a misfit stream because it doesn't fit into the river channel that it's flowing in. The river channel was for a much bigger river. In between where the river was originally flowing, there's still going to be the scar of the river channel on the Earth's surface, and that's what we call the wind gap. Right here, where the actual interception took place, we call that the elbow of capture. Another diagram just showing us these same features. So here we've got before capture and here we've got after capture. This is a diagram that I actually took from a previous exam paper, so you can see what it is. So we have river P is flowing over here, and it's an energetic river. There's headward erosion, and it erodes backwards, and eventually it's going to intercept river S that we've got over here, intercepts river S, and in fact then steals the headwaters. So this river down here, this was river R originally, is now going to be rejuvenated because there's a lot more water flowing in this river. It is then also called the captor. So now the captive river, this little one that's left behind, this we refer to as the misfit. I love this picture here. You've got a little boy with his dad's clothes on. The clothes are much bigger than what he is. So here at this misfit, the river channel is much bigger than the river flowing in it. It's a misfit. Of course, here we said again, where the river channel, the sky is still there, we call that the wind gap. All right, let's just look at all of these features once more. The captor river is the energetic stream that has got the headward erosion. That's eroding backwards and actually intercepts another river. The captured river, it's the river that's having its water stolen. Misfit stream is the little stream that's left afterwards that doesn't fit with the channel that it's flowing in. Elbow of capture is the point where the interception actually happened. Wind gap is that scar on the Earth's surface where the river channel is still there, but obviously has no water flowing in it anymore. And then here we've got something else. We've got a waterfall, and often a waterfall will form near the elbow of capture, or at the elbow of capture, where the river has been rejuvenated. That's often a feature that you find there. So that's it. Grade 12, we've got another I would say section, another bit here. It's just where rivers are cutting through mountains. Now there are two different scenarios here. The one that we're looking at now is the antecedent drainage pattern. And it's a bit confusing, but just bear with me here. Here we've got the river itself is older than the structure that it flows through. All right, so let's just have a look at that. We have a river flowing here on the surface. You can see it flowing there. Underneath, we've got the strata, different layers, and that's happening. Now, over thousands, millions of years, tectonic forces on the Earth's crust start pushing up these layers, and they form a mountain range. You can have faults where a whole block of strata is forced up, and these mountain ranges that are formed here, the river is still eroding all along. It's eroding, and the force that is pushing up these layers is happening slowly. So as it's forcing up, the river is still eroding. So what it means is that the river was there before the mountain range was. So the mountain range has come after the river, therefore the river is older than the structure it flows through. The other one we've got here is the superimposed drainage pattern, where the river is now younger than the structures that it flows through. So let's look at this scenario. Here we've got the river flowing on the surface, but way underneath the surface there is some more resistant rock. It's covered by layers of softer sedimentary rock, and the river is eroding and going on. So as the years go past, millions of years, the softer sedimentary rock is eroded all around here, and the river is still flowing. The river is flowing now, and it starts cutting through this more resistant rock. However, this resistant rock has been there for millions of years. It was buried under the Earth's surface. So in other words, that mountain range is older than what the river is. So the river is younger than the landscape through which it flows. Thank you.